Hello scholars, sorry I couldn't be with you today. Go ahead and pause the video so that you can do the objective and do now while students come in. Okay, so you went over the do now here. You know that metals have a low electronegativity and nonmetals typically have a high electronegativity because of where they are on the periodic table. Metals are on the left, and we know that to the left is low electronegativity. Nonmetals are on the right, and we know to the right is high electronegativity because of protons and electron shells and all that. Alright, so we're going to do a video lecture. Here's the video you can search for. If it doesn't pop up, try Papa Larks as well. And then I want you taking notes on a separate piece of paper. So get some paper ready, pause this video, and then start this one when people are ready to take notes. Okay, so you're back. Oh, what's that? Oh, it's a baby with the hiccups. Oh, she gets the hiccups a lot. Yep. Okay, so that was your daily dose of cuteness. I'll stop that eventually, maybe. We'll see. Okay, so you're going to read and annotate page 14 and 15. You can do this individually and then complete as much of page 15 with your partners as you can. All right. Let's say 5 minutes of practice on page 15. You might not finish the entire thing, but you should finish at least, 5 to 10 rows of it to get some good practice just of the different properties. And then go ahead and go to the next slide and do the next activity. So now what you're going to do is you're going to do a card activity in your groups for page 16. You'll be given a set of model cards, assuming that we can find them without me there, but I'm pretty sure that it'll work out. You're going to work with your group and sort them into ionic, metallic, and covalent compounds, so those 3 categories. And then you're going to use information from the cards, and you're going to fill in the chart on page 16. So when it says connectivity, strength of bond, etc., you're going to fill in information on that chart using those cards. If you finish, I want you to actually go back to the previous lesson, because I don't know if you got all the way through the practice on page 12 and 13, and actually do anything you didn't get to do. Okay, so you've done the card activity. So now you're working on practice for electronegativity and atomic radius that you didn't finish. It starts on page 11, but I'm pretty sure you got that done. You definitely should have. But then page 12 and 13, you might not have gotten all the way through, so now's a good time for you to go about doing it. If you finish these pages, then you can work on homework page 5. Page 6, you could give a shot, but I'm going to have you do that for homework over the weekend after the lesson on Friday, because Friday will prepare you a little bit better for that lesson. Okay, when you're ready, you can pass out the exit slips and then pause this video because I'll go over the answers to grade them. Okay, so you've done the exit slips. Go ahead and get a grading utensil out, a different color than you wrote with, and let's grade them. So this first one, why does aluminum conduct so easily, or any metal? Include a model in your answer. So metallic bonding consists of cations surrounded by a sea of electrons. That's a key term right there, this sea of electrons. You could have also said delocalized electrons. Since the metals have a low electronegativity, the electrons can move anywhere and thus can conduct electricity. And then I just stole the diagram from the reading where it has fixed cations, which means they can't move, and a sea of electrons, these negative, can move around at any time. So check for the model. So that's 3 checks for number 1. Number 2, some solar power plants use molten, which is melted, salt to store energy at night when the sun is not out. Would these containers of molten salt conduct electricity? Why? Include a model. So yes, they would. That's a check. Melted ionic bonds allow the crystal lattice structure to break, and the ions can move around freely. And so charges can move and electricity can be conducted. So then here's my model. Something like that should be good. So that's 3 for both, so the total's out of 6. You can keep that to study, or you can post it on the student work section if you did a good job. Okay, if you still have extra time, do homework, and then the last minute I want you to go over the reflection and feedback. Think about how did you do today, and you've got one more day without me. So let's make sure it's a good report. End well, right? All right, bye-bye.